Okay. Hello, everyone, and welcome to Concordia University's Fourth Space. And thank you for joining us for today's event, AI and Sustainability. Now, to help situate you, we're streaming this to YouTube live from Fourth Space. We are located on unceded Indigenous lands in Tiohtià:ke, Montreal. Just so you know, here at Fourth Space, we work with our university community to help mobilize knowledge. We co-create daily activities that examine research questions, like today, and projects in development here at the university. We're running this event as a live stream meeting. So you have comments, you have questions, just put them in the chat and we'll try and get them to the appropriate person. Those of you in the space, just hold on because there's going to be a poster session in the second half where you can ask questions, etc., of the different very short presentations we're going to for this event. That's the first part. Is going to be a series of, I think it's 24 very brief introductions really to the kind of to these projects. That's the live stream component. The second part after that, for those of you here in the space, sorry friends on Zoom, we'll switch our screens to multiple posters and have a more informal kind of more poster session. Thank you all for trying this out with us. But with that, it's very much my pleasure to hand this over for an introduction from the program director for LEADS, which, as we all know, is Leadership in Environmental and Digital Innovation for Sustainability. Also professor, Geography, Planning, and Environment, Damon Matthews. Damon, thank you.
Thank you, Doug. Well, thank you everyone for coming. It's so nice to see a full room. So yeah, as Doug said, apparently you all know what LEAD stands for, so I don't need to say anything. I imagine that's not completely true. I know a good part of you are in the LEADS program. For those of you who are not, welcome. We're very pleased to be co-sponsoring, organizing this event with the Applied AI Institute. And so we're going to have a joint poster session about, half of the presenters are from the LEADS program, the other half are from the Applied AI Institute. And so, the point is to meet people, get to know some of the other research that's going on in this interface space of AI and sustainability. The LEADS program has been running for about 3 years now. I guess we're in our 4th year. We've had about 40 students participate in the program so far. This is the 4th event we've organized this year. And the goal of the program is to train graduate students and expose you all to new skills and ideas at the interface of digital tech and sustainability science, to think about how we can use new technologies and new innovations to accelerate transitions to a more equitable and sustainable world. So we're really happy to be here with the Applied AI Institute today. I think that's all I'll say about the LEADS program for now, and I will turn it over to Tristan, who will introduce the Applied AI Institute briefly. Thank you.
Thank you, Damon. And good evening, everybody. It's really great to see so many people here. I think we may not have enough seats for everybody, so that's really great. I just wanted to say a few words to introduce the Concordia Applied AI Institute. Just to say that the Applied AI Institute is a research unit which aims to support multidisciplinary research in applied AI. So AI and put whatever you want after that. So for today, AI and sustainability, we are very happy to co-organize this event with LEADS. And I also wanted to tell you that while the main goal of this session is to mingle and exchange ideas and see how AI could be used or how sustainability questions AI and how these two domains can join forces and be looked at together, the Applied AI Institute also has some mechanisms to support research. So in case ideas emerge and you're looking for ways to implement them, to support them, I'm going to mention a few of them. So we have a technical team, first of all, represented here by Valeria Kebets, who's sitting there. And so this team is led by Valeria, has 2 engineers and a few research assistants who can help design AI models, train things, do the technical work that is not always easy to do in labs which don't have a technical focus. So that's number one. The AI Institute also has working groups, which are funded groups to help support focused research activities. So it could be, for instance, AI and sustainability. They can fund a few hours of research assistance per week or that kind of things. We also have dedicated funding in case research is with external partners, companies, or nonprofits. We have funding programs to support that. And finally, we have a seed program to support for something like between $10,000 and $15,000 to support a research student, a research assistant to implement a research project. So just wanted to say that concrete mechanisms to support potential nice ideas that would emerge from this session. If you're interested, feel free to reach out, and I wish you a nice and successful event.
Okay, now I guess I'll go to the first slide. Brianna, you are first on the list here, so thank you very much for being so brave.
Hello, my name is Brianna Bird, and the goal of my project here was to gather perceptions on leveraging AI to monitor and report on biodiversity among biodiversity and ecosystem scientists. So biodiversity and ecosystem scientists are doing the research, are doing the science, and AI scientists are making the tools. So with this, we were hoping to get perceptions from these scientists on how the tools can be better developed to also include biodiversity goals. So we did this through a survey of GeoBond's community and did some qualitative and quantitative measurements of the responses. I performed some topic modeling to kind of get a consensus from our respondents on the opportunities and also the barriers that biodiversity and ecosystem scientists believe currently exist with AI tools and research.
Thank you, Brianna. I didn't read out Brianna's title, which was AI for ecosystems. Next up, we have Fatima with developing a benchmark data set and open repository for water main break prediction models, which I have to advance the slide.
Good afternoon, everyone. I'm excited to share an insight into the pressing issues that affects our community and infrastructure, which is water main breaks. Our ability to predict the water main break is hampered by the absence of the standardized data set to predict the water main breaks and compare these models efficiently. We create an open repository of machine learning models on GitHub dedicated to water main break predictions. Our approach involves meticulous data preparation to address the inconsistency, normalize features, and also execute feature engineering. We are developing machine learning models using a robust algorithm like XGBoost and like GBM. Our study offers a path toward the proactive management of the water distribution system with the establishment of an open repository. This will help to the refinement of the models and also to the adoption of the best practices for the predicting the water main breaks in the different cities. Thank you.
Thank you, Fatima. Next up, we have Faye with collective intelligence in the digital age, facilitating dialogic education on climate science with GPTs. Okay.
So many of you probably recall having some very heated discussions about climate change. And one reason that this often happens is because climate change concerns not just numbers and stats, but also society and economy, which can make it a very polarizing topic. And it also doesn't help that there's quite a lot of misinformation and disinformation online. So my research investigates ways that GPTs can facilitate climate education and communication through a dialogic approach. And this is meant to encourage skills building for creative thinking, critical thinking, communication, and collaboration. And these skills are especially important now because environmental action and policy decisions are collaborative problem-solving endeavors that involve individuals from multiple backgrounds and perspectives. And I believe that AI can become a really powerful tool in facilitating this process. Thank you.
Thanks, Faye. Next up, we have Isra, individual household electricity load forecasting using historical smart meter data with neural networks.
Good afternoon, everyone. First, I'd like to thank you for this opportunity to share my research that focus on individual household load forecasting using smart meters data and with a neural network. My research has two main questions. The first is how can we enhance the neural network how can we enhance the individual household load forecasting with the instability, uncertainty, and the individual influence of the human behavior. And the second is, can the neural network, specifically the feed-forward neural network and the layer recurrent neural network, give a reliable solution for this challenge? Now to express why this research in particular is important in 2024, the increase in energy need and the increase in the concerns of climate change has led many researchers forward this. The residential load forecasting, specifically the individual household, has played a crucial role in the grid stability. So as we move toward more sustainable future, it's important that we focus on the individual level of consumption to build more continuous and efficient future. Thank you so much.
Next up, we have Jennifer with remote sensing, machine learning for biodiversity monitoring, a case study in Quebec's forests.
So hello, everyone. My name is Jennifer. My research question is, can we estimate species richness in Quebec's forest using optical remote sensors, environmental and climatic data? And this research is important because we are currently living in a biodiversity crisis, and the majority of the world's wildlife depends on forests in some way. So the ability to monitor the state of tree species richness remotely at large scales can improve management decisions, highlight biodiversity hotspots, and allow us to track changes through times on a large scale. Thank you.
Next, we have Yami, public behavior-driven design of policies for urban waste management, and management in smart cities.
Hello, I'm Hamed, and I will present it on behalf of my colleague, Ms. Yang. The project is about creating AI tools for finding the causality behind the policies, for example, waste management policies. For developing their tools, they need to understand the environments and human behavior. For understanding human environment, they will use the environment-based design methodology to understand the environment of the policies. And for understanding the human behaviors and the implementation barriers of the policies, they use the task frameworks. These two task frameworks and the EBD both developed in the Concordia Design Lab. And the AI tools will be used for to extracting the information from the textual data, from the comments and things that existed on the webs. For example, comments about the policies, they can extract the elements and finding the implementation barrier of the policies. Thank you.
Next, we have Megan, SAI for environmental preservation, other sustainability science research that could leverage AI tools.
Yeah, so broadly, my research questions relate to behavioral flexibility in primates. I'm really interested in understanding their full ranges of typical behavior. Specifically for the project that you'll see on my poster later, my research questions are: how did Japanese macaques solve multi-destination travel problems? Are decision-making rules being used? And do social and non-social factors influence these choices? And then why is this research important to me? Is I've always loved animals, so I feel really lucky I get to study their behavior and just hang out with them. But the more I learn about them, the more you learn how smart they are, and understanding how resilient they are just normally without all of the human-induced impacts is really amazing to see. But it's also like this foraging experiment itself is a really good tool of creating accessibility into non-experts into like behavior science and that world. We ran an event this past summer where 150 people got to participate. So I really like that aspect of it as well.
Thanks, Megan. And what I read wasn't Megan's title. Next, we have Nayusha, enhancing water demand forecasting, leveraging LSTM networks for accurate predictions.
Hi everyone, good afternoon. I'm Nayusha. The representative of our research group consists of Melika, Helia, and Murad. As you can see in this poster, the main focus of our research is to forecast urban water demand in water distribution networks. And as a crucial part of water distribution networks, we need to forecast water demand to define operational plans. And in fact, in water networks, we have nonlinear nature and we've got stochastic demand patterns. And that's why we need AI to help us to predict these water demands. And to do so, we use LSTM, long, short memory networks to help us. And in addition to that, we use some weather-related parameters to help us. And in conclusion, we implemented our model in 2 case studies and got brilliant result and just proved that AI can help us in demand forecasting very well.
Next, we have Morad, leak detection with economics-driven convolutional neural net.
Hi, everyone.
Go for it.
Sure. Hi, everyone. I'm another member of the Urban Links. I'm here presenting my research, which is about leak detection. As we have a high volume of water leaking in the water distribution, in the developed countries, we have up to 30%, and in developing countries, we have up to 50% leakage in water distributions. And as climate is changing and we have a population growth and a water shortage, this comes to the point that we need to detect these leaks and prepare them. My research is about using CNN, convolutional neural network, to detect and locate these leakages. The innovation in my research is using the loss function, which is not only concerning the previous metrics like the accuracy or F1 score, it is more real life metric, which is considering the location for the crew repair costs. And it is trying to minimize this value. And this is used on a synthetic data set, which is using the EPA net networks. And this is that all. Thank you.
Thanks, Brian. Next, we have Olivier, enhancing wildfire behavior and fuel characterization in the University of Victoria Earth System climate model using artificial intelligence in the context of nature-based climate solutions.
So hi everyone. Yes, my title is long, I know. I'm a first-year PhD student, and today I'm going to talk about my research proposal actually on enhancing the wildfire prediction into the youth model using AI. And I'll be looking at the different components inside the fire scheme and how we can use AI to better represent them, to assess the vulnerability of different natural-based climate solution or carbon storage in future climate change scenario. Thank you.
Rebecca, represent simulating agriculture as a nature-based climate solution using the University of Victoria Earth System climate model. Also,
good afternoon. My name is Rebecca, and my research focuses on using agriculture as a nature-based method of carbon dioxide removal to mitigate climate change. So our main research questions are A, how well does it work? And the good news is that it does, yay. And then the second thing that we focus on is what happens to the division of carbon pools. So what we want to know with climate change is one of the big areas of uncertainty is how well soil can take up carbon in a changing climate. So this addresses this in the context of carbon dioxide removal, where the carbon goes into soil in agricultural areas, just to see what happens to carbon pools and what other aspects of the climate may change as a result of it. Thank you.
I believe Samira is here. Yes. Hi, Samira. Leveraging machine learning to uncover environmentally harmful chemicals and to achieve the Sustainable Development Goals. Go.
Hello, everyone. I'm Samira. Our research is developing model using AI to screen potential POP-like or PBT chemicals. And they're using this model. We decided to identify POP or PBT-like chemicals, which are less known in environment. Thank you.
Thank you. Next up, we have Sarah, an integrative, multi-level sustainability assessment framework for organizations leveraging artificial intelligence.
Good afternoon, everyone. Have you ever wondered how organizations today are measuring their sustainability performance, or what steps they're taking to actually be on track? Well, in fact, new research from Bain & Company shows more than 60% of organizations are in fact off track to meeting their sustainability goals. This is a pressing issue in the world where the demand for environmental responsibility is at an all-time high. Today, I'm excited to share insights on my research, which tackles the challenges organizations face in managing, assessing, and reporting their sustainability performance. My research seeks to address three pivotal questions. First question is, I'll look into how sustainability indicators are selected to assess their environmental, social, and economic performance. The second question looks into what differentiates the relative importance amongst these sustainability indicators. And lastly, I'll be exploring their complex relationships between the interdependencies of one sustainability indicator over the other. Through artificial intelligence, I'll be using a tool that recognizes the interconnected dependencies of these sustainability indicators to enhance a more holistic sustainability assessment approach. Now, why does this research matter, you may ask? Well, in a world of economic crises, environmental uncertainties, and social challenges, their organizations need to be accountable, transparent, and proactive in their sustainability efforts. So in conclusion, my research provides a practical approach for organizations to adapt to changing environments, prioritize their resources effectively, and continuously improve. It's an invitation for all of us to embrace on our journey to a more sustainable and responsible. Thank you.
Thanks, Sarah. Next up, we have Xian. Insights into the urban municipal solid waste generation during COVID-19 pandemic for machine learning analysis.
Good afternoon, everyone. My name is Shuyan Wang. I'm a PhD student under the supervision of the Dr. Chunjiang An. And there are two questions to be solved in this research. First is to test the model, the performance of municipal solid waste prediction model during the COVID-19 and focus to the accuracy decline and the error distribution. Second is to seek some proxy variables that are not involved in the traditional prediction model as new predictors to enhance the robustness and the performance of the solid waste prediction model. Although COVID-19 has been announced to be ended, but I think everyone has learned its impact to everyone's life. So I hope the result of this research can provide some insights to the municipal solid waste and help the policymakers to make the contingents to make the urban more to enhance the urban resilience. Thank you.
Next is Shilin, enhancing public transportation reliability under climate change using deep learning approaches.
Well, thank you for the introduction. I'm Shelin Tian, and I'm a PhD student from BCA department at Concordia, and currently I'm in my third year. I'm so glad to have this opportunity to share my research about the deep learning applications in transportation reliability under climate change. And here are two facts that about the public transportation I want to share with you today. Let's take Toronto as an example. The average daily delay time for a subway network is around from 2014 to 2022 is about 200 minutes, and that is 3 hours and a half per day. And if the climate remains stable, the provincial and the municipal governments would spend nearly 14 billion annually in public transportation maintenance, and that is a big if. So what worse is that the change in extreme weather are adding $1.5 billion per year to this cost. So my research is going to explore the following questions. How has climate change affected the reliability of public transportations, and how much has it increased the problems with transportation being unreliable? And what are the future trends of the reliability of public transportations under different climate change models in terms of the scenarios? And thank you so much.
Next, we have Yuan Ling, AI-powered decision-making for participants in smart transactive energy systems.
Yeah, good afternoon, everyone. My name is Yuan Li. My supervisor is Dr. Jun Yan, and my topic is AI-powered decision-making for participants in smart transactive energy systems. This topic is under the background that traditional power grid has been transferred into a smart transactive energy systems. Based on the development of the information technology and the renewable energy. So a variety of participants has appeared into the stage, including the prosumers who not only consume the energy, but also provide the energy to the market. So the challenge is that under such complicated and dynamic environment, the decision making of participants with the purpose to maximize with purpose to achieve their goal is challenging. So the objective of this project is to explore the potential of AI in supporting the decision making of participants in the transactive energy systems. At the same time, the decision making can improve the overall social welfare, optimize the grid operational efficiency, and also minimize the non-green energy consumption to achieve the sustainability. Because the sustainability sustainability of the society is not only the things of the government, but also the things of everyone. I, as a researcher, is willing to find AI solution that can power the decision making of individuals, not only to benefit themselves, but also to benefit the entire society. Thank you.
Armin, enhancing the sustainability of eco-driving by deploying efficient algorithms for vehicle routing problems.
Good afternoon, everyone. Thank you for granting me this opportunity to present. My research is focused on optimizing vehicle routing algorithms to boost efficiency and reduce emissions. In 2024, with climate action more critical than ever, leveraging AI for sustainable transportation is not innovative, it's essential. My work seeks to refine BRP algorithms, aiming for a dual benefit, a substantial cut in emissions and a move towards safer and smarter transportation systems. This work is not just about technological innovation. It's about shaping a future where progress and sustainability go hand in hand. Thank you.
Next up, we have Edgar, prioritizing future nature-based solutions through reinforcement learning to reach Canada's biodiversity and net zero emissions targets.
Hello, everyone. So as some of you might know, Canada is trying to reach the 30 by 30 goals. So maybe no, conserving 30% of land by 2030, and there are also the net zero emission goals. And so AI so far has tried to contribute to sustainability in terms of, let's say, predicting biodiversity or carbon stocks, and probably that, and it will sure help to reach those goals. But we haven't used so much reinforcement learning to try to see where are the priorities for conservation or where are the priorities to avoid land use emissions. So what we've been trying to do here is trying to prioritize future nature-based solutions to simultaneously reach the 30 by 30 goals and also like avoid carbon stock losses. So basically, I've been exploring two scenarios that I'll be happy to talk about. So one is just about prioritizing areas to conserve biodiversity and avoid the costs of anthropogenic pressures. And a second scenario that tries to maximize species conservation, avoid anthropogenic costs, but at the same time, try to avoid the losses of carbon stocks. So thank you very much.
Thank you, Camillo. Next up, we have Hari Krishnan and Ganesh. And information retrieval technology to assist journalism research.
Hello, everyone. So we're excited to share a collaborative research work that with computer science and journalism department. So we're exploring how computer-assisted analysis informs climate change and how it's being reported, and through evolution, how it's been like changed in the way of reported. And we can analyze the regional aspect as well in this. And we've employed a low-level AI tool in using information retrieval for analyzing extensive news corpora. So we can, it will be useful for the journalists to like access the data and make insights on like a huge corpora. And this is like in the early stages. So thank you for your attention for this thing. And
Malika, framework for predicting water main breaks in the face of climate change.
Hello, everyone. I'm here to present my research on water main failure prediction in the face of climate change. Water mains are affected by climate variables, as seen in the top right figure. And in this research, we try to find out how climate change would affect failure rates of water mains, which further help us to improve the rehabilitation programs. Each year, a significant amount of funding is spent on water main rehabilitation. So it would be better to identify the vulnerable areas to manage these resources. A deep learning approach, specifically LSTM, is utilized in this research, and the results suggest that all climate change scenarios would lead to an increase in water main failure. And for different materials, this effect is different. So this should be considered in the rehabilitation programs. Thank you, everyone.
The next one is a team, I believe, involved that includes Sebin, but for information retrieval technology to assist journalism research again? No, I'm reading the wrong title. I'm sorry. We're going to skip that one and we could come back to it later.
To the next one, yeah.
All right. Noah David. Spongy moth densities in Quebec forests, prediction locations of low density reservoirs.
Hi, I am a PhD candidate in biology, working with Emma Duplat and Carly Zeder. And for my research, I'm exploring biotic and abiotic variables that may impact densities of spongy moth populations. Now, the spongy moth is an invasive defoliator of softwood and hardwood trees in North America, and it experiences outbreaks that are periodic and somewhat unpredictable. So for this poster specifically, I focused on the in-between outbreak periods, and I'm trying to identify variables that might help us figure out where these reservoirs of spongy moths are at in between outbreaks so that we can find them, follow them, and try to predict upcoming outbreaks and hopefully minimize them. So I've done one field season for that. There's one more to come, and I would love any feedback on analyses or anything. There's preliminary results there and more to come. Thank you very much.
And our last presentation of this series, Impact of the Car Fleet, Evolution on Electricity Demand in Quebec. Frederic.
All right. Bonjour tout le monde. Hello, everyone. So with the 2030 plan for green economy of Quebec to have 2 million electric vehicles in the province, and the goal to also phase out the sale of fossil fuel powered vehicles by 2035, we need to assess how much power will be needed by those electric vehicles. And that's what we did here with the SAAQ, so Société de l'Assurance Automobile du Québec data from 2011 to 2021, encompassing about 9.7 million vehicles and 225 million transactions. With that, we observed that the fleet has grown by 11 kilograms each year since 2011, and has grown by about 70,000 vehicles each year. With those forecasts, we can then assess the electricity demand, specifically with the temperature in Quebec, which is like not ideal for electric vehicles. And we also did a life cycle assessment comparing the cradle to grave emissions of electric vehicles and internal combustion engine vehicles. Thank you.
Okay, thank you, Frederick. Thank you, everyone, for those impossibly concise presentations. Very much. Well, the whole point now is to kind of have a chance to get deeper into each of those projects. But thank you also for people who are online on Zoom attending there. We're going to be closing up the Zoom and live stream now. But also a quick reminder that this part of the event, it was live streamed to YouTube and is available there if you want to like it and share it. Of course, please join us again for another event here at Fourth Space. And for those of you here in the space, we're going to do a little switch around. Our two large screens in the space, one facing us right now, the one facing out on the street. They're going to show four posters each. The first 8 people will be the first ones we'll show. And a few minutes after that, we'll switch to the next group of 8 and then again. So then that gives you a chance to talk to one another, mingle around. That's it for me. Thank you again.